Okay. Well, I've just gone through some mathematics here, which is, well, there it is. You can see it. It's pretty dull. Basically, what I'm showing is that if x1 is a random variable with moment generating function m1 of t, and x2 has moment generating function m2 of t, then it's a bit like logarithms, because the random variable x1 plus x2 has got moment, that sort of like maps over to that, has got moment generating function m1 of t, m2 of t, if x1 and x2, x1, x2 are independent. Okay, so let me just rewrite that out again. If x1, you sometimes write that symbol there for independent, and x2 are independent, you don't put the comma in, then that implies that m, the moment generating function of x1 plus x2 as a function of t, equals the product of the moment generating functions m1 of t, m2 of t. Observe carefully that the implication doesn't go the other way around. If the moment generating function of the sum is equal to the product of the moment generating functions, then the random variables x1 and x2 are not necessarily independent. It's a thing called sub-independence, and my goodness me, that is a weird concept. Okay, so let's have a look at that. We'll just have a quick, I could give you the mathematics of it, it's all here, but it's dull as ditch water. All you need is that. If they're independent, then x1 plus x2 has got a moment generating function of m1 of t, m2 of t. How about that? You see, this is quite hard to calculate. That's a terrible thing. That's got summations and integrals and all sorts of rubbish. That's quite hard. Okay, so I'm just going to leave that there. Done.